In this video, we're going to learn how to solve these JAMB Maths involving indices. Alright, so after going through this video, basically I can tell you guys that you will be able to simplify problems you meet in JAMB Maths under indices easily. Alright, so indices happens to be one of my interesting and most loved topics in mathematics. Alright, so let's get started, guys. So this question one, we have simplified this. Alright, now all you need basically for this question is apply the law of indices and get the answer straightforward. I know this kind of question, since you guys calculator in JAMB is not scientific, let me show you. There's no way you can simplify this straightforward on this calculator. This is basic calculator. You cannot do it. No way. Had it been this a scientific calculator, this question would have been a child's question. Just punch it in the calculator, just get the result. But since we don't have scientific, so let's solve it manually. Let me show you guys how you can also go about this and get it done easily. Okay, so let's begin. It's one, we have it's one the power minus 3 by 4. So you need to break it down. Follow me, guys. This is very simple. I'm going to show you guys. Minus 3 by 4. Okay, to break this down, this thing is the same thing as fourth root of 81. Alright, include the brackets. Then we have the power negative 3. Now, note that whenever you have this kind of expression, you have the power to be a fraction. The denominator of that fraction is a root value. Alright, had it been what we have here is 2, this would have been square roots. Okay, and if it is 3, it will be cube roots. That is 4, is fourth root. If it is 5, it will be fifth root. Alright, so in that order, let's proceed. So fourth root of 81 is 3, guys. Basically, it's 3. Let me show you how you can verify. Fourth root of this is 3. Now, when you check 3 times 3 times 3, okay, times another 3, what the output is 1. So we have to up with 4 times. So this shows us that the fourth root of 81 is what, 3. Remember, we are in the process of breaking this down to get this done. Alright, so this will be 3 to the power minus 3. Okay, so 3 to the power minus 3, can just remove the bracket and this structure. This is 3 to the power minus 3. Alright, so indices again, this is inverse law. So another way I can express this is 1 over 3. Okay, to the power 3. To the power 3. Yes. So this is another way you can express this. Alright. So if you break this down the more, you're going to have 1 over, I know 3 to the power 3 is 3 times 3 times 3, which gives us what? 27. So 3 times 3 is 9, 9 times 27. So we have simplified this now, this expression. So see, I'm breaking it down. So let's go to the next one. 25. This 25 to the power 1 over 2 is very, very simple. The power 1 over 2. But what I explained here, this is roots. So this will give us square roots of 25, which will give us what? 5. Alright. Remember, the power, the numerator is the power. This is 1. If 1 to show complete work, it is to the power 1. Alright, so this is square root of 25 is 5. So this will have been this to the power 1, which is something as 5 to the power 1, which gives us what? 5. Alright, so this is 1, guys, not 2. Let me write it where that I'm not confused with this. So this is the power 1. Okay, so I'm making progress. The last one we have, we have 243, the power 2 over 5 as usual. So this will now be fifth roots. So if you're breaking it down, it will now be fifth roots of 243. Alright, you include the power 2. Okay, so the fifth root of 243 will still give us 3 as output. Let's verify with the calculator. Let me show you guys. So this will be when you check 3 times 3 times 3 times 3 times 3. What's the output? 243. So the fifth root of 243 is still what? 3. So when you keep simplifying this, we now have 3 to the power 2. This is same thing as 3 to the power 3 was 9. So now that we have broken these values down, then bring them together. So the first one, we have 1 over 27 times this one, we got it to be 5. Alright, times this one is 9. Okay, this one is 9. Remember, 3 square is going to be 9, correct? So when you break this down, you're going to have 9 times 5, 45. You have 45 over 27. What can divide through? 3 can, okay, let's say 9 can divide through here. 9. 9 to 45 will give you 5. 9 into 27 will give you what? 3. So the correct answer to this question option was B. Option B, 5 over 3. So you see how easy it is. Although it might take you a little time to arrive at if you not try not to use these laws fast. But if I'm the one doing this, do not take me this time. Or just that I'm explaining. Alright. So that's how to go about it. 5 over 3. So it's as simple as this. Let's go to the next question. We are going to pass with 5 questions. So after solving the 5 questions with you, you can follow the processes I will be explaining and solve whatever problems you meet under Indices. So let's remove this and go to the next question. Alright, question number 2. Okay, so let me wipe this. So question number 2, we have evaluate this expression. See the same law of indices. Alright, so we are doing with indices, guys. So this will be, if you want to break this down, alright, when you have this kind of question, we are going to start with, you need to get the exact base to be the same. Alright, now we have the base there is 16, the base there is 16, the base there is 2. Now we need to make them to correspond to 1. And for us to make it happen, we need to make the base to be 2. So another way to express 16 to the power 0.16 for the base to be the same, to equate these two here, this will give us 2 to the power 4. Our 2 to the power 4 is 16. 2 times 2 times 2 times 2, that's 16. So this will give us 2 to the power 4 times 0.16. Alright? Times 16 to the power 0.0 is something as 2 to the power 4. Okay? Times 0.04. Close the brackets. Then times the 2 we have here. 0.2. So the base is not the same. Apply the law of indices again. This time around, you apply the multiplication rule, which says that when values are multiplying together and the base is the same, you add the exponents or the power. So this is going to give us 2. Just take one base and add the powers or exponents. So this will give us 2 to the power. We have 4. Okay, so you can now break this down with the calculator. So this is 4 times 0.16. Okay, plus, or let me, before we punch in a calculator, let me finish simplifying it here. I think that's going to be confused. We have 4 times 0.16 plus, we're adding the powers, alright? 4 times 0.04, okay, plus 0.2. So when you add these things together, 4 times 0.16 plus, okay, we have 4 times 0.04, okay, plus 0.2. What's the output? We have it to be 1. So basically, since we have it to be 1, This is something as 2 to the power 1. Or 2 to the power 1 is something as what? 2. The correct option in this question is what? Option D, which is what? 2. So it's as simple as this. Let's go to the next question, question number 3. Alright, so let's wipe this. Okay, so we have to evaluate this. This is also under indices, alright? So for this question, as usual, you are going to apply a lot of indices to them, to these values, okay? So let's begin with a2 in bracket, it's 1 over 16 to the power 1 over 4. So this, we have 81 over 16 to the power 1 over 4. Okay, now, as I explained before, the denominator here is 4 when it comes to this power. Alright, so this 4 now is a root bar, this is fourth root. So what this means now is I'm going to have fourth root of 81 over 16. Okay, so when you break this down, fourth root of 81 is 3. And fourth root of 16 is 2. Is 2, yes. Remember, we did something like this the first question. So when you check 3 times 3 times 3 times 3, you give it to 1. So the fourth root of 1 is 3. Fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. So that's how you do this thing, guys. Basically, in JAMB Maths, you usually experiment with the roots of a value that is 3, 2, 5, 4. Alright, this common value do not give you an odd value, just give common values below. So that's what you should expect. So now that I simplify this is 2 over 2. Then we have times 2 whole number, no times 2 to the power negative 1 rather. So 2 to the power negative 1 is same thing as 1 over 2. Okay, so basically the final result should be 3 over 2 times 1 over 2. So we give us what? 3 over 4. And that will be the answer to this question, 3 over 4. So unfortunately, we don't have the correct option in this question. Alright, so the correct option, the correct answer to this question is 3 over 4. Now the correct answer in this option. Alright, so this is the right answer to this question. Alright, so that's it. Let's go to the next question. Look, the next question. There is an error in the options we have here. The right answer is 2 over 4. Even if you just use your scientific calculator to punch these threads, you're going to have 2 over 4. Alright, so let's go to the next question. Question number 4. Okay, let's wipe this. Okay, so in this number 4 question, we ask to simplify this. This is so simple, guys. Let's just write out the question. So we have 3 to the power of n minus 1 times 27 to the power of n plus 1 over 1n. So law of indices again. So we are going to make the base to be 3. All the bases we have here to be 3. Alright. So this is going to give us 3 of n minus 1 times. Now, 27 is something as 3 to the power of 3. Alright, because 3 times 3 gives you 27. 3 to the power of 3 in bracket n plus 1 over 81 is something as 3 to the power of 4. Okay, so once you have done this, the base is now equal. So let's firstly apply the division law of indices, which says that when the base is the same, you subtract the powers. Okay, so this will give us, if you do this, you're going to have 3 to the power 3 in bracket n plus 1 minus. So we have 3 to the power 3 in bracket n plus 1 bracket close minus 4 in bracket n. Alright, so this is what we're going to arrive at when you simplify what we have here. Let's now connect everything together. Remember, this is same thing as 3 to the power n minus 1. Okay, divide 3 to the, okay, sorry, this is my one, we are dealing with multiplication. Let me know this. Okay, so we now have 3 to the power of n minus 1 times 3 to the power 3 in bracket n plus 1 minus 4 in bracket n. Sorry. So remove this bracket we have here. So that's it. When you now apply the multiplication law of indices at this juncture, the final result will be, let me write it here, it will now be the base is the same, you add the powers. So it will now be 3n minus 1 plus, okay, we have, when you simplify 3 times n, it gives you 3n, okay, plus 3, 3 times 1 is 3, minus 4n, okay. So when you break this down further, you collect like terms. When you collect like terms, it will be n plus 3n. Okay, let's just do it together gradually. So we have 3n plus 3n. If you are collecting like terms, okay, minus 4n minus 1 plus 3. Alright, so when you break this down, you're going to have n plus 3n, that's 4n. 4n minus 4n is 0. So we have, which will give us 2. So you will have 3 to the power 2. So when you simplify 3 to the power of 2, that 3 times 3 which equals 9. And that will be the answer of this question. The correct option is option C, 9. Okay, so that's it for this question. Now let's solve the last question, and after it we can call this a class. Okay, so let's get to the next question, question number 5. Let's wipe this. Okay, so this question number 5, we have if 27 to the power x plus 2 divide 9 to the power x plus 2 equals 3 to the power 12, find x. So this is also law of indices. Let's find out the question. We have 27 to the power x plus 2 divide 9 to the power x plus 1 equals 3 to the power 2x. Okay, so we are going to make the base to align. So 27 same as 3 to the power 3 in bracket x plus 2. Alright, so we have divide 9x then as 3 to the power 2 in bracket x plus 1 is 2, guys. Okay, equals 3 to the power 2x. So when you simplify this, remember the law of indices, the base is the same. When you apply division law here, this lesser equation, the base is the same. So you are going to take one and add, subtract the powers. So this is the same thing as 3 to the power. When you break down, okay, let's just do 3x plus 2 minus 2 bracket x plus 1 equals 3 to the power 2x. Okay, so at this juncture, this base can cancel this base we have here. Alright, so we now have 3, simplify the bracket, so we have 3x plus 3 times 2, 6 minus 2x, okay, plus 1, sorry, minus 1, minus 2, rather, minus 2 times plus 1 give you minus 2, okay, equals 2x. So when you collect like times, you're going to have 2x minus 2x plus 6 minus 2 equals 2x. Alright, so 2x minus 2 gives us x. So we now have x. 6 minus 2 will give us 4 plus 4 equals 2x. Alright, so this will now be, you collect like terms. This 4 will cross over the quantity sign. This x will cross over the quantity sign, change to negative x. So we're going to have 2, we're going to have 4 rather equals 2x minus x. So your 4 will not be 2x minus s will give us was x. So the value of x is what 4. The correct option is question is option C. Alright, 4. So it's as simple as this. This is basically how you can deal with problems involving indices for your JAMB Maths. I just give you guys a process you can follow. Alright, so hope there's something interesting from this video. All you guys need now is to practice something so that you will get used to these laws, how to apply them, and of course become faster at resolving problems around them. Alright, so that's the key, being able to solve questions and getting them correct at a very fast rate. Alright, so hope there's something interesting for this video. Let's go to the video, guys. If you are new to this channel, ensure that you are subscribed to this channel and by hitting the subscribe button for more videos. Also like, share, and comment on the video. Let me know how you people want to learn from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave your question in the comment section below and I will ensure to give you a response. So that's it. Now click the end screen above and I will see you in the next video. Thanks for watching.